Peter Czanik, and we'll talk about syslog-ng for DevOps. I'm from Hungary, community manager at Babelfish, the upstream developers of syslog-ng. Babelfish is an IT security company headquartered in Budapest and has over 150 employees. As most of us are engineers still, so about 2/3 of us can still configure a Linux kernel, which is quite an achievement, I think, at this size of company. So let's talk about logging. I guess everybody in the room agrees that logging is not just cutting trees. Logging is also recording events on a computer. Here you can see a log message. This one comes from an SSH login, and as found usually under var log messages. But of course there are also many other log messages. Syslog-ng is an enhanced logging daemon with many input and output possibilities, and has a quite flexible configuration language. That was why it became popular about 15 years ago. And because of this, it was also often referred to as a Swiss Army knife of logging. Syslog-ng developed quite a lot over the years. Originally, it worked with legacy syslog messages, or RFC 3164, but it was adapted to work also with the new IETF style syslog messages. You can see the difference here on screen. The first one is what most people are used to on their machines, and the second one is the new standard message, which, as you can see, carries a lot more information than the old style syslog messages. It also has it has a more precise timestamp, and not only a log message, not only a message, but also name value pairs, which makes searching for log messages a lot more convenient. The problem is that as far as we know, less than 1% of installations utilize this new syslog protocol. Syslog-ng can classify and structure logs using built-in parsers, and it can also work with JSON-based messages, which are getting more and more popular recently. Here is a JSON message, and syslog-ng can also both parse and emit these kind of messages. And recently, the input and output possibilities were extended heavily, like using of message queues like AMQP, were added databases like PostgreSQL or MongoDB, and that's why recently quite a few users started to call syslog-ng a Babelfish. I hope everyone knows this from Douglas Adams' Hitchhiker's Guide to the Galaxy. Of course, syslog-ng is still not able to route messages from any system to any other system, but we are working on it. In this presentation, I will talk about a couple of use cases how syslog-ng can be used, and also present the related configuration files for it. So first I will show how a syslog-ng configuration file looks like. Oops, microphone is getting in the way. Can you still hear me? Okay. It starts with a usually with a version number. Sometimes there are some minor changes how syslog-ng interprets a given statement in the configuration, and it gives a hint what to do. The next one isn't strictly necessary, but often quite useful. SCL stands for syslog-ng configuration library, and it's a collection of plugins and configuration examples which can extend syslog-ng conf without putting all of the details into the file. Okay, I still okay. Syslog-ng works with a pipeline-like configuration. It defines sources where messages are coming into syslog-ng. Like in this one, system stands for regular syslog messages, for devlog or kernel messages, and system hides away the details from the configuration. So, for example, it's useful when migrating from System 5 to System D, where usually one needs to rewrite the configuration file to from devlog to run system D journal syslog. But if you have this in your config, then you don't have to care what is your log source. It will cover you. Internal stands for internal messages for syslog-ng's internal messages like failed network connections and stuff like that. And this one is commented out UDP network source. The next one is a file destination, and that's why I told you that it's a pipeline. The log statement is the pipeline that, which glues all of these together. The source, there could be multiple sources, multiple destinations, and as we will see later, filters and other things will also be here in the log statement. So here is my first example, receiving an email about each root login. Syslog-ng can send emails about messages. Of course, it's not a complete SMTP server, so it needs an SMTP server to achieve this. And of course, one needs syslog-ng. And syslog-ng, if there are, if you provide it with message examples, then it can parse messages and create name value pairs from the messages, and it has many different filters. So one can filter for the root users. And at the end, if there is a match, it can send the results off to an SMTP server. Before showing the configuration, I would like to talk a few words about message parsing. The first parser is a CSV parser, which can parse columnar data into fields. A typical log source for this is Apache logs, where you have a well-defined log structure. Here you can see the different columns: client IP, names, times, and so on. Then a destination file is defined, but here is a trick. One can use the results of the parsing in the file names, like here the username is used in the file name. It's appended to the file name, and if there is no username in the Apache logs, then no user is logged here. And here is the log statement which glues all of this together: the source, the parser, and the destination. The next parser is DB parser, or often also referred to as pattern DB, which is the database behind DB parser. It can parse information from unstructured messages like the SSH login or other log messages. If there is an XML file describing the log messages, I will show you pattern DB. It's an XML file, and at first sight it's ugly as hell, but one can get used to it, and it works quite nicely. Here is the actual pattern describing the log message. Accepted. It's from the it describes the SSH login. So one can see the fixed parts like accepted, for, and from, and so on, and also the parsers for creating the name value pairs from the variable parts of the message, like authentication method, the username, and so on. This is the part which is strictly necessary for pattern DB, but it can also be extended, like here is a test message, so one can easily validate the message with test values, and one can also give additional name value pairs based on the message content, like here that it's a login, that this login was accepted, that and other information about the log message. Oops. Okay, finally. The next parser is the JSON parser. I will talk about it later. Filtering. This was the next to the configuration language. The many filters were the most interesting parts of syslog-ng earlier. There are many kinds of filters: Boolean operations, comparisons, content-based filtering, and all of these work not just on the whole message, but also on fields extracted by the different parsers. Here is an example taken from the syslog-ng configuration in OpenSUSE, which combines many of these. Here we filter about the kernel facility. It's for IP tables messages. The first filter is for kernel messages, and we also look at the message that it needs to contain in and out. And of course, all of these are connected with the Boolean operator AND. So if all of these match, then all of these are true, then it's very likely an IP tables message. So let's see the SMTP configuration. First, we define a parser for and here we load the database I've shown you previously with the SSH logs. Here is a filter which checks if the username equals to root, and here is an SMTP destination. The SMTP server is on the local host. Here is the from and the to fields set, and the message is written to the message body. One could use here one can easily format here the message using the fields extracted from the original log message. And here is the log statement which glues all of these together: source, parser, filter, and destination. The next use case I would like to talk about is logging anonymized JSON messages to MongoDB. For that, one needs log messages in JSON format, like from Node.js or Tomcat or just about any application. Of course, one needs syslog-ng and the MongoDB server. MongoDB is quite interesting as unlike traditional SQL servers, it can store just about any name value pairs. It doesn't have a fixed table structure, so it's an ideal destination for PatternDB for name value pairs parsed by PatternDB or any of the other parsers. How it works: the JSON parser parses incoming log messages and turns them into name value pairs. One can apply here a rewrite rule. For example, in Germany, one is not allowed to store the IP address of website visitors, so those can be anonymized. Or in PCI DSS, one needs to anonymize the credit card numbers in logs. And at the end, syslog-ng sends the name value pairs to MongoDB. Syslog-ng can manipulate log messages in many ways. One doesn't have to think about that it's falsifying log messages. The reason is often that the application analyzing the log messages needs a specific format to deal with, and by default this is the message, the template which is used for storing messages. The date, host, message header is the program name and process ID, and at the end the message. And it can be changed freely. One can add here the additional name value pairs or just about anything. One can also rewrite log messages, like I mentioned, that anonymizing IP addresses or credit card numbers. And for credit card numbers, I already mentioned SCL. We have a configuration snippet for anonymizing credit card numbers. Let's see it. Here it is. Here is a very nice regular expression describing credit card numbers. It's I didn't write it, but next, there are two different possibilities for anonymization here. The first one replaces the credit card number by a hash. The second one is replacing the middle of the number with stars. By default, it's working on the whole message, but it's better to feed it with as small data as possible, as regular expressions, and are very expensive operations, computationally intensive. So it's better to use it on as small data as possible. And let's see the actual configuration for it. Oops. If you don't use the include SCL-conf include in your configuration file, then this is the way to include it. And next, we define a source for JSON-based messages. It's a TCP port, and we use flex no parse, as by default all incoming messages are parsed as syslog messages, and JSON messages can also come directly as in JSON format, but of course they can also come as part of a syslog, regular syslog message. Here we define a JSON parser, and prefix here means that for any name value pair found by the parser, we give a .json prefix. This way, later on, it will be easier to find those name value pairs extracted by the parser. Here we define the MongoDB destination. By default, it connects to the local host, and what we do here, that we don't store the rest of the name value pairs, just those extracted by the JSON parser. As other way, syslog-ng generates many different name value pairs related to the message, like the reception time, the source of the message, and so on, which are not always strictly necessary when storing a message. And here is the log statement, which glues all of this together, the source, the parser, and here is the rewrite rule. And as you can see, we don't parse the whole message here, but only work on the field which contains the credit card number. The next example I would like to talk about is sending logs to message queues. as especially in the telecommunication industry, but also often in web services. The business logic of the operation is based on message queuing, and syslog-ng already can feed it. Right now, syslog-ng can support the AMQP and STOMP destinations, but as we have quite a few Google Summer of Code students this year, we will have soon support for 0MQ source and destination, and also AMQP source will be ready by the end of the summer, hopefully. As usual, syslog-ng does the parsing and filtering, and at the end it sends off relevant messages to the message queues. Here I want to show just a very quick short destination. It's the MQP destination with all the username, passwords, and here you can see that we send only those name value pairs which start with AMQP. Real-time statistics is getting more and more important, especially in the DevOps world, and here also we have some new developments. Redis and riemann destinations were added recently, so we can feed these statistics related servers with name value pairs. As usual, syslog-ng does message parsing and filtering, and at the end it sends off name value pairs to redis or riemann. And let's find configuration example. Here we deal with Apache logs again. The source, it's a Apache log file. The parser we have seen previously, and here is how the Redis destination is configured. As we can see, and the user agent data is sent for every minute, so one can see statistics how which user agents were used by visitors in each minute, and all of this data, all of these logs are glued together again with the log statement, the source, parser, and the Redis destination. Recently, the syslog-ng Incubator was introduced, which contains modules which are not yet part of syslog-ng for various reasons. Usually, these are modules which are still in heavy development, and while many people are using them in production, like the riemann destination, but they are expected to change still a bit. And once we see that they are mature enough, we plan to integrate them into future syslog-ng releases. I already talked about riemann destinations. destination. The next one is Lua destination. Syslog-ng configuration is quite flexible, and we have many different destinations, but still not everything is possible. So Lua destination was added where the whole message or name value pairs are forwarded to Lua, and it can do with it whatever it wants. And the Lua's and it's not external but embedded. The Lua interpreter is embedded into syslog-ng. For example, we already have an Elasticsearch destination written in Lua. Python and Perl destinations are under development. They are already in Git, but not yet in a release. For those people who love to use browsers for reading logs, an RSS destination is ready. There is also a graphite template, so one can see nice graphs about what's going on in the machines. And there is a monitoring source. It's also based on Lua. It's executing a script on a predefined interval, so one can easily feed any of these statistics outputs or do anything with it. There are packages for Debian, Fedora, OpenSUSE, and Ubuntu, and it's also in FreeBSD ports already. It's a little known fact, but syslog-ng is always packaged for OpenSUSE first. I'm the packager, and why it's because developers are working on features, new features and bug fixes, and they don't really have time and energy for packaging, and I'm doing some of the packaging work, and my distribution of choice is OpenSUSE. So I'm the one who finds those changes which affect OpenSUSE, which affect syslog-ng packaging as I package syslog-ng. My packages are available in my home directory on the OpenSUSE build service. There are packages for OpenSUSE and SLES. I try to keep functionality as close as possible. Obviously, the enterprise server packages sometimes lack a few features due to lack of related dependencies. My syslog-ng packages are first tested from here, and if I find it stable enough, those then packages goes to base system. One side note is that make check doesn't run in the build service, only for local builds, as OBS is too restricted, and networking related tests don't really work in OBS. And if anyone wants to check out the incubator features, then it's dependent on 3.5, which is also available here in my home project. Any questions?
How does this relate to the journal thing? How much is duplicated function? How much is competing approaches? And what's your opinion on that, or your knowledge?
When we first heard about the journal and what is it trying to achieve, we were very afraid that the journal will kill syslog-ng. We soon learned that it's not the case, as syslog-ng, the journal is pretty much focused on desktop users. I would say it's for only for local logs. syslog-ng works for yes, the main strength of syslog-ng is central logging. The journal is Linux only. syslog-ng runs just about on just about anything. And also I always hear quite a lot of complaints about the journal doesn't really work reliably, it crashes always, while syslog-ng usually works. Of course, with OpenSUSE 12.3 we had some troubles with syslog-ng as well, but it was luckily fixed quite quickly.
Thank you.
Hello. I have maybe just one practical question. Is there a way to queue messages when destination is a remote computer, and at some point you have a network breakdown or something like that? And what happens with messages that were supposed to be sent in that period?
I'm in a difficult situation here, as yes, there is, but that's not the open source edition. It will hopefully reach it sometimes. I was complaining about it for years now. It's on camera, so I shouldn't have told it. But there are workarounds, but of course proper disk buffering would be better. It's a schizophrenic situation for me to talk about it.
Okay. Is there, does, for example, ZeroMQ maybe help in
yes,
that?
it could help, or one can use larger buffers. Of course, if you have high message rate, that doesn't really help.
Yeah. Okay, thank you.
Wouldn't it just work? Well, that's a capacity question, of course, but wouldn't it just work that you make a message queue destination? Well, I have the logic. I just want to pass it through a message queue, then the buffer is in the message queue, but yeah, you need the logic somehow. Yeah. Okay, doesn't work so easily as I thought. Okay, thanks.
Do you sometimes wish there would be a more structured log format by default, not just parsing strings to guess what's in it?
Sorry?
Do you sometimes wish there would be a more structured log format, like JSON by default,
yes,
for example?
Actually, I was working on the CEE board that stands for Common Event Expression. That was a standardization body by the US government, but after a few years it was shut down before it reached working standard. and there the main goal was to describe any event with name value pairs, as those are much easier to work with than just free format messages. And the transfer protocol was syslog, and inside syslog JSON messages were embedded. But while it was a very nice idea, it turned out to be a holy grail of system logging. So it was never really accepted as a standard.
Okay.
Any other questions? Thank you for listening.